Section 2 is going to focus on some of the unique elements of circles. So we're going to start with a central angle. And a central angle is an angle whose vertex is at the center of a circle. And so if we think about a circle with a center here, a central angle is any angle that pulls out like that. So there could be one there could be one off here, and that central angle is going to have unique properties, which we'll talk about later. Our first theorem is the congruent circles theorem, which says two circles are congruent if and only if their radii are congruent. And remember, that works both ways. So if you know congruent circles, then you get congruent radii, or if you know congruent radii, you get congruent circles. And that should feel pretty good because the circle radius is really the only movable dimension, so to speak, of a circle. So true or false? The circles at right are congruent because their central angles are equal. So if you see this one here, here's my center, I have a central angle here for that circle, and then that exact same central angle lines up here. And this, of course, is false because clearly the blue radii is bigger than the red one. So it does not meet that criteria of that earlier theorem. The central angle doesn't have anything to do with it. Now, a couple other interesting pieces of a circle. First one is called an arc, and it's a continuous portion of the curve of a circle. So if you think about a circle with its center, an arc is any piece along this edge of a circle. And we have several specific kinds of arcs that we talk about. A minor arc is an arc that is less than 180 degrees, and it is named by the endpoints. So if I go over to my circle here, and I'm going to call it circle P, and I'm going to give some points here randomly. For example, arc from D to E would be a minor arc. And we use the notation of an arc right over the arc. A major arc is an arc that is greater than 180 degrees, and it's named by the two endpoints and 1 point on the arc. So if I go over to my picture here, for example, and I start at D and I go all the way around to G, that's clearly more than 180 degrees. And so I could call that arc D, E, G, endpoints and a point on, or I could call that same arc D, F, G. The key is the endpoints and then any point in the middle. Now a semicircle is an arc which equals 180 degrees. And so that is one that has to basically go through, my diameter would be here. It is the half circle arc right there. Okay. And that is also named with 3 points, like a major arc. And so, for example, this would be arc QXR. Arc measure is a degree measure for the length of the arc. Now, we talk about different units when we talk about length. We talk about feet, we talk about meters, we talk about miles, inches. Arc measure is a degree measure, so we talk about an arc being a certain number of degrees. Later, we'll talk about arc length, which has a different unit of measure, if you want to think about it that way. And so when we talk about arc measure, the central angle measure equals the arc measure. So whatever our central angle is that cuts that arc off, so let's say this is 62 degrees, then this arc, which we'll call PQ for circle R, the measure of PQ is equal to 62 degrees because the central angle and the arc have the same measure. So let's look at an example. Given circle Y down here, find angle AYC. So AYC. So we're finding angle. And so notation is super important. Well, all the way around a circle is 360 degrees. And so in this situation, I have 360 degrees would be equal to 110 plus 90 plus the angle I don't know. So I have 110, I have 90, and the one I don't know. And when you work that out, we end up being angle AYC being equal to 160 degrees. If we are talking about classifying the arcs in this picture as major, minor, semicircle, arc AB, A to B, is 110, and so that means it is a minor arc. Arc A to C, we just found out, is 160 degrees, so that is also a minor arc. Arc A to B stop at C is greater than 180, so that is a major arc, and it's 200 degrees, just for reference, 110 plus 90. And ACB, A through C stop at B, this one actually ends up being 250 degrees, therefore it's a major arc. If we look at one more video here, one more example, we are going to find X in this picture. Now remember, I just said the total circle is 360, and I have an expression, an expression, an expression, an expression, and then something I don't know. But if I remember back to earlier sections, I have unique angles here that make those V's. They are vertical angles, so that means that this angle right here is also 5x plus 5. And so I can add all of these things up and do 5x plus 5 plus 8x minus 4 plus 13x minus 3 plus 5x plus 5 plus 20x. That will all equal 360 degrees. So if we clean up the algebra a little bit, I have 51x plus 3 equals 360. Subtract 3, 357, divide by 51, and I come up with x equaling 7. Go ahead and give the practice problems from your homework a try, and tune in to the next video. I'm not